So this is the 21st lecture, and in the last lecture I told you about the K-map, and the function of the K-map is to minimize the Boolean functions. Any Boolean function, in order to minimize, we use some graphical method that is called a K-map, and how to frame the K-map, that I have discussed in the last lecture with you. Now today the topic that I will discuss is grouping in K-maps. How do you simplify the Boolean function? Let's take, for example, I told you that suppose you have 4 variable K-map. Suppose f, a Boolean function or a Boolean expression, is a function of 4 variables a, b, c and d. Now how to frame the K-map, that I have already told you. I'll start with 4 variable, so automatically 2 and 3 will be clear to you. So 4 variable K-map, I told you how to frame this 4 variable K-map. That is, I take a rectangle or a square and I divide this into 16 cells. Each cell corresponds to a max term or a min term, depending whether the problem is of a canonical SOAP form or a canonical POS form, or I can say whether the problem is sum of min terms or product of max terms. So here I take on this side a, b and c, d. A, b can have values 0, 0, 0, 1, 1, 0, 1, 1. Similarly, c, d can have this values. So I write this 0, 0, a bar, b bar, 0, 1, a bar, b, 1, 0, a, b bar, and 1, 1 is a, b. This is for a min term. If every cell is representing a min term, or if the expression is in canonical SOAP form, or if the expression is the sum of min terms. That is, if you have, okay, I'll discuss it. This is c bar d bar, this is c bar d, this is cd, and this is cd bar. Then I told you how to write the decimal equivalent of this. On the bottom here, on the right bottom of every cell, I write down the decimal equivalent 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. How do you obtain these decimal equivalents, that I have already discussed with you. Now the point is that, suppose I say that a function is given to you. For example, suppose I say that it is given that f, a Boolean expression, is a function of a, b, c, d. Suppose I say that it is equal to summation 0, 5, 10 and 15. Now if it is a sum of min terms, these are the decimal equivalent of min terms. So very first thing what you do, that you simply substitute a 1 on these positions. So what I do, I substitute a 1 at this position, I substitute a 1 at 5, I substitute a 1 at 10, and I substitute a 1 at 15. The first step is that whatever is written here, whatever min terms are provided to you, decimal equivalent of the min terms are provided to you, what you do, very first thing is simply introduce a 1 here. Simply substitute a 1 on these positions for sum of min terms. If it is sum of, this sigma is sum of min terms. On the other hand, if it is a max term, suppose it's a max term here, and suppose I say that I make K-map for a max term for 4 variable. Just see, I make it again for a 4 variable. I divide again this into 16 parts, since it is 4 variable. On one side, suppose I take the variable a and b on this side, a plus b I'll write for max term, and here I write c plus d. Otherwise you can write a, b and c, d only. The point is only to represent this. So now this will be a plus b. This factor is a plus b. This is a plus b bar. I have discussed already this thing with you. This is a bar plus b bar, and this is a bar plus b. Similarly, here this factor will be c plus d. This factor will be c plus d bar. This factor will be, if you see, this factor will be c bar plus d bar, and this factor will be, if you see, it is automatically c plus d bar here, and not c plus d bar, it will be yes, it has to be A plus B. I hope that this is clear to you. It is just as I told you, nothing but simply the bar of this or the complement of this. Complement of this will be this much. Complement of this will be A plus B bar. Complement of this will be A bar plus B bar. Complement of this will be A bar plus B. So this factor will be A bar plus B. It will be C bar plus D, not C plus D bar. Just see. It is 0 0 0 1 1 0 1 1. 1 represents the complement and 0 represents the variable, so it is C plus D. Decimal equivalent are same as I told you. It is 0, 1, 2, 3, 4, 5, 6 and 7. This is 8, 9, 10, 11, 12, 13, 14 and 15. Now, if the expression is given to you or if the problem is given to you as a product of max terms, suppose I say it is given to you f a b c d, means a Boolean expression which is a function of 4 variable a b c d and it is product of certain max terms. Pi means product. Suppose I say it is given to you 2, 7, 8 and 13. Suppose this is given to you. So what I do in case of max terms, first thing I substitute a 0 on these max term positions. So you have 2 here, this is 7 here, this is 8 here and this is 13 here. So what I do, I substitute a 0 on whatever max term positions are given to you. So first point is that I substitute a 1 on min terms position and I substitute a 0 on max term positions that I provided to me, but before that I have to frame a K-map here. So I hope that this is clear to you. Now after this, the second step that we do, first is insertion of 1 and 0. 1 and 0, depending whether it is a 1 for a SOAP form and 0 for a POS form, or I can say canonical SOAP form, 1 for a min term position and 0 at the max term positions according to the problem that is given to you. This is the procedure that we are going to follow. Now next comes, as I told you that the major application of this is to minimize the Boolean function. Now this minimization is done by grouping this, by grouping these cells, by grouping these max terms or min terms here. Now these grouping can be done in 3 ways. It can be a group of 2. It can be a group of 2. I can say it is group of 2, either max terms or min terms. I am not writing, that's why. A group of 2 is called a pair. Then it can be a group of 4. It can be a group of 4. And a group of 4 is called a quad. And third can be a group of 8 cells. I can say 2 cells, 4 cells, or it is 8 cells. And a group of 8 cells is called an octet. It's called an octet. Remember that this grouping is done in this form, 2 to the power n, where n is an integer. So the group of 2 means 2 to the power 1, group of 4 means 2 to the power 2, group of 8 means 2 to the power 3. You cannot have a group of 5 cells. This is wrong. Or you cannot have a group of 6 cells, because 5 or 6 cannot be expressed as 2 to the power of any integer. So it is either 2, 4 or 8. Of course it can be 16 also, double octet, but here we will discuss 2, a pair, a quad and an octet. Now, and how to solve this, that I'll tell you now. Now suppose I say that you have, let's take for a min term first. Suppose you have a problem here. Suppose this is the situation. This is a K-map for 4 variables I am drawing for min terms, for 4 variables. Suppose it is this much. I divide this into 16 parts. On one side it is AB, on the other side it is CD. This side, this side. A bar, B bar, A bar, B, AB, AB bar. Then this is C bar, D bar, C bar, D, CD, and this is CD bar. and I write down the decimal equivalent of this. The decimal equivalent of this 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Now suppose I say that I give you a problem. Suppose I say that simplify this f, which is a function of a, b, c, d, is equal to summation. Suppose I say that this is equal to summation 1, 3 and say, let's take a small problem. It is 13 and 15. That's all. So very first thing, it is a sum of minterms. So first thing, I substitute a 1 on these positions. 1, 3. This is 1, this is 3 and this is 13 and 15. This is 13 and 15. Remember that the grouping can be done either horizontally or it can be done vertically. Horizontally or vertically. Diagonally not possible. So now what I do, and it is done for the adjacent cells. For the adjacent cells. So a grouping, I make a group of these two. Look at these two terms. I make a group of these two terms. Then I make a group of these two terms. Let me take one more figure here. Let me take one more number here. Suppose you have 1 here and a 1 here also. Suppose I say that here you have 10 and 14 also. This is 10 and this is 14 also. So I make another pair of this. A group of 2 is called a pair. Now what is the value of this actually? This complete expression, if you say it is 1, 0, 0, 0, 1. If I say that this expression is a bar, b bar, c bar, d plus 3 is 0, 0, 1, 1 plus a bar, b bar, c, d and so on. This is this big expression and I want to solve this by K-map. Now I found that there are 3 pairs here. Now what will be the value of this pair? Suppose I say, I name this. Suppose I say that this pair, I name this as first pair. Now suppose I name this one as second pair. And suppose I say that this as third pair. So final expression, my final expression f, which is a function of a, b, c, d, will be the corresponding value of first pair plus the corresponding value of second pair plus the corresponding value of the third pair. That is, this is in canonical SOAP form. I am minimizing this in the minimized SOAP form. From canonical SOAP form to SOAP form, this is what I am doing here. Now what will be the value of this? What will be the value of this first of all? Let's take first pair, this is this. What will the value of this one? Now what I do, I project this vertically for both. The value is AB. For this minterm it is AB, for this minterm it is AB. So I can say that it is equal to AB from vertical side. From vertical side this is AB. Now look at the horizontal side here. This is C bar D and this is CD. This variable C is changing from C bar to C, but this D is constant here. If you see, it remains unchanged. So I write the value of the unchanged variable. So it is D here. So value of this is equal to ABD plus. Look at the second one. This is ABD. Look at the second one. The second group or second pair I can say. Look at the vertical side. On vertical side it is A bar, B bar. On vertical side this is A bar, B bar. So I write this as A bar, B bar. On the other hand, on the horizontal side, look at the horizontal side. Look at this horizontal one. Again, this C is changing from CR to C and this D is unchanged. So I write the value as D. I hope that this is clear to you. Third group, just see. Look at this third pair here. In this third pair, if you observe this third pair, go to the just projection on the vertical side. This B is changing from B to B bar. This A is fixed, so I write this as A. And look at the horizontal side. On horizontal side, it is C D bar for this also, and it is C D bar for this also. So it is A C D bar, means this expression. The final answer is this by grouping. I hope that this is clear to you. Now suppose, let's take another example. This is for a minterm where I have taken certain pair. How all pair can be formed? Let's take another example. So for pair also, another possibilities of pair. Okay, before I come to this, what are the other possibilities of pairs? Let me take it here. I'm not taking a problem. What are the other possibilities of a pair? How pair can be formed? I'm not writing the decimal equivalent. I say that this is AB here. On this side it is AB, and on this side this is CD. Say this is A bar B bar, A bar B, AB, AB bar. Then this is C bar D bar, C bar D, CD, and CD bar. Now the possibility is that you can have a 1 year and a 1 year, for example. Of course, a pair can be made. Similarly, here a pair can be made. Another possibility, let me tell you, you have, of course, the value of this will be A bar B, and from this side D is common, so it is A bar B D. Now another possibility is that you have a 1 year and a 1 year. I can make a pair with this and this. This is called folding. A term is called folding. What I am doing is that I have folded this. I have folded this K-map about this center line. It can be folded only about this center line or about this center line. Not about this, not about this, or not about this and not about this. It can be folded only about these two lines. These two center lines. Vertical and horizontal center lines here. It can be folded about these two lines here. So what will the value of this? If you see, look at the horizontal side. When it is folded here, it is A B bar and it is A bar B bar here. So the variable which is unchanged is B bar. So I can say that the value of this will be, the value of this particular pair will be B bar, and look at the horizontal side, it is C bar D. So the value of this is C bar D. I hope that this is clear to you. Let's take another example. For example, suppose I have a 1 year and a 1 year. Again I can fold this about this center line. This particular center line, I fold it about this. Just see. I can fold about this. And what will be the value of this particular pair? Only the value of this pair. The value of this pair, if you see, it is equal to, just see, the value of this pair from here. Look at the vertical side. It is AB. AB for this as well as AB for this. So I write this as A, B. On the other hand, just see the horizontal side. It is, this D is changing to D bar and C is fixed. So A, B, C. I hope that this is clear to you. So this is called folding. Folding can be made between these two. Folding can be made between these two. Folding can be made between these two, and so on. So I hope that this pairing is clear to you for a minterm, and what is the resultant minterm for, what is the resultant product for this, minimized product for this. I hope that this is clear to you. Let's take the case of maxterm also, that suppose a problem is given for a maxterm. For example, let's take, suppose you have a 4 variable K-map here. An expression or a Boolean expression is given to you for 4 variables. Now see, again AB on this side, A plus B I am saying, and C plus D on this side, because this is a maxterm. Maxterm means it is a product of maxterms. Product of maxterms. Now AB can have value 0, 0, 0, 1, 1, 0, 1, 1. CD can have value 0, 0, 0, 1, 1, 0, 1, 1. So I am writing this in variable form. I'll write here A bar, I'm not sorry, A bar. It is A plus B. I have written here a plus b. This quantity is a plus b. Please, if it is not clear, I am writing here. It is a plus b. This will be a plus b bar. This quantity is a bar plus b bar. This quantity is a bar plus b. Similarly, this quantity is c plus d. This quantity is c plus d bar. This quantity will be 0 0 0 1. It should be 1 0 here and 1 1 here. This quantity is c bar plus d bar, and this quantity here is c bar plus d. Decimal equivalent, as I told you, it will remain the same either for min term or max term. 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 and 15. Now suppose I say that the problem given to you is f, which is a function of a, b, c, d, is equal to product of certain max terms is here. Suppose I say it is equal to 0, then 3, then 7, and suppose I take only this much, 8. That's all. Now what I do, very first thing, as I told you, since it is a product of max terms, so in max term position I substitute a 0. I substitute a 0 here at 0, then I substitute 3, then I substitute here and at 8 at the decimal equivalent these positions. Now how to frame the pair. If I can say, I cannot make a pair between this and this, but yes, I can make a pair here. This is a pair. First pair is this, and the second pair is this. I fold it about this. So now my function f, a, b, c, d, from canonical pause to simplified pause. This is what I am doing here. What will be the result of this? If you see, suppose I name this as pair 1, and I name this one as pair 2. So this is equal to pair 1 into pair 2 and pair 2. So what is the value of pair 1 first of all? Look at this in the vertical side. This is a plus b and this is a plus b bar. This b is changing from b to b bar, so it is a. So I write this as a from this side. From this side, it will be c bar plus d bar. So it is a bar plus c bar plus d bar. I hope that this is clear to you. Next is this one. If you see, look at this. This I have done. Let's take this one. Now in this, look at the vertical side. In the vertical side, this is a plus b and this is a bar plus b. The variable which is unchanged is b. So I write this as b. Vertical side, it is c plus d. For this also it is c plus d. For this also it is c plus d. So b plus c plus d. This is my final answer. And this is how I have minimized this particular expression into this pause form. From canonical pause form to pause form. I hope this is clear to you. In the next lecture, I'll tell you how to frame a quad and how to frame the octet and what will be the resulting value of it. So I'll stop it here. Thanks for the time being.